let's get started. And thanks everybody for coming to the your UC Ag Day. And then I'm Guan, associate professor at the College of ACES. And today I'm gonna share some of my research related to cover crop. And the work that we've been done is through the collaboration with multiple professors in the campus, including Maria Villamil, Andrew Magnot, Dan Schiffer is our collaborator from IFCA, Professor Emerson Knifesinger, and also the researcher Lowell Gentry. And then the research is funded by Illinois, NRAC, and USDA. So, for this crowd of people, don't need to spend a lot of time talking about cover crop. So this is a cover crop. We're gonna really primarily focus on the two types of cover crop in our landscape. One is legume cover crop, one is non-legume cover crop. And to give a little bit detail, legume cover crop is what you usually hear about hairy veg and the clover. That these are the type of the cover crop that has the ability to fix the nitrogen from the atmosphere to become the nitrogen that plants can use. And then so this is a particular kind of the cover crop. The other cover crop, we just say non-legume cover crop. They don't have the ability to fix nitrogen, but usually these are the grass type of cover crop that has a good ability to absorb nitrogen from the soil. And then usually also has a high NC ratio. And then so a typical non-legume cover crop or grass type of cover crop is cereal rye that is very popular in our landscape. Okay, so these two type of cover crop, and then so in terms of the cover crop benefits, there are multiple cover crop benefits that people usually talk about. One is reducing nitrogen leaching, and then so the cover crop really being there, they can take the residue left on the soil from the nitrogen fertilizer, the unused ones, and then thus leads to a reduced nitrogen leaching. The second aspect that you're gonna hear more and more about is the benefits for the soil carbon. In general, soil organic carbon will increase under the situation of you growing cover crop, and so that's also a benefit. And the other benefit that people also talk about and has been seen is the weed suppression, erosion, as well as help the hydrological conditions. And so, given all these soil carbon, given all these benefits for the soil health, the cover crop is an important conservation practice to benefit to your field, benefit to your farmland. And then, however, cover crop adoption is very low. And then there are multiple reasons that leads to this. Practically, our cover crop growing season is very short. And we're going to talk about harvest from the previous growing season to the coming spring that you're planting. That's a window that's not quite long, and it's pretty cold. So for cover crop to develop, they usually require the temperature, thermal conditions. So in general, we are not don't have a very ideal condition to grow cover crop. At the same time, cover crop costs money, and then so farmers, whether they think cover crop is economically viable, do they see the benefits of growing cover crop that can bring the benefits in the long run? Is a question. Like I think it's a practical question that farmers is trying to figure out. At this moment, at least we know that if you grow cover crop, you spend resources to buy seed of cover crop. You're gonna actually chemically terminate the cover crop. That costs money, and then the benefits, if they are not obvious, then that makes farmers hesitate. Okay, so with all of that, so our studies is really try to practically understand in that relatively small window that you can grow cover crop between the two seasons of traditional conventional conserving rotation system. How are you going to feed the cover crop in? And then so if you look at this, cover crop only going to happen when you have the planting window that around the harvesting time, and then the termination window when you start the second growing season. And then so during this period of time, that's pretty much the cover crop growth window. But this cover crop growth window is pretty short, and then it's pretty cold too. So developing cover crop really requires the thermal conditions. So this is one aspect that make the problem quite challenging. The other aspect of the problem that you make the problem quite challenging is you don't want a cover crop to become a competitor of your cash crop, right? You don't want that's the case. If you let the cover crop continue grow, especially in the early, late spring, that creates a situation that there is a moisture in the soil, that there are inorganic nitrogen from the mineralization of the soil. So they are there that potentially can be used for the coming growing season cash crop. But if you let cover crop continue grow, they may take too much of the resource that you're supposed to reserve for your cash crop. But now it's being taken by cover crop. And so there is a trade-off that you're going to really deal with. There's a trade-off that you're going to really deal with. So let's just kind of repeat that trade-off. What's that trade-off? One aspect of the trade-off is that you want a cover crop to grow longer time and grow larger, because that's how you gain the benefit of growing cover crop. Okay, so in general, growing larger cover crop, bigger cover crop require longer growing season, and then that leads to bigger cover crop, larger cover crop, leads to the situation that you can take more unused nitrogen into the cover crop. You can actually take more biomass, grow more biomass, and actually generate more soil carbon benefit, soil carbon increase. So all this requires to grow longer season of cover crop. But at the same time, if you continue to grow longer season, you create the situation, especially in the springtime, that if you continue to let the cover crop grow longer, it actually take the resources that's supposed to be used by the cash crop, and then you start to let the cover crop become the competitor of your cash crop. Okay, so you want to avoid that, and that's a trade-off. So, and that's a management practice that you really need to think about if you want to use cover crop. And then so I in my first try of the presentation, I talked a lot about kind of methods. So I kind of, in this second try, I learned my lessons. So I gonna really jump to some of the conclusion without bore you onto too much technical detail. But I still want to let you know a little bit is the study we did is really rigorous. So what we did is we worked with, as I mentioned, scientists and agronomists that set trials across the state. So they grow the cover crop across the state, across multiple years, and then really capture the ground truth data. And then, so that's very valuable data set. And our second speaker will talk about a lot of these work. But for me, I think these are the ground truth data very valuable. But can I, get most out of these data? And then the way that I'm doing so is bring these trial ground truth data with models, and then to first let the model see whether the model can reproduce what you observed in the past with the right process. And if that's the case, then we basically can trust the model to make some extrapolation into different crop types, into different soil types and weather types, as well as make let the model guide some of the management practice. So this is exactly what we did. We use a model that has a pretty sophisticated process that has the water budget, try to simulate water, nutrient, carbon, and all crop and soil conditions. So holistically. But then whether the model works or not, the best way and the only way is to use the ground truth data to verify. So we actually look at our ground truth data, and then so these are the comparison between ground measured data, and then these are the simulation. And this is the one-to-one line. If everything sits in the one-to-one line, it means our result is good. The model simulated in the correct way. And the situation is that we did look at the result. We find that the result is robust for both simulating crop yield as well as simulating biomass of the cover crop. So with that type of the validation, we gain good confidence that we potentially can use our model to do some extrapolation. Now get back to our question, trade-off question. How do you determine the cover crop for growing season length, and then such that you can actually deal with that trade-off? So what we did is, again, it's a little bit complicated graph, but let's focus on the termination part. The planting part is similar. The termination part is if you terminate late of the cover crop, you let cover crop stretch to the further of the spring, you will in that case, basically if you terminate April 1st or versus you terminate at the end of April, you're gonna really allow cover crop to grow larger with that biomass. But as a consequence for corn yield, you actually gonna, if you terminate cover crop later, you're gonna actually reduce your yield. And this is particularly a problem if you grow cereal rye, non-legume cover crop, followed by corn. So this, you're gonna expect to see that if you terminate the cover crop too late. Okay, too late. The impact is much less so, or almost can be negligible if your cover crop is legume cover crop, or if your cash crop is soybean. In those situations, it's much less so. The particular case that you're gonna really need to manage and be aware is when you grow cover crop you grow cereal rice as cover crop, followed by the corn, as a cash crop, and that's when these termination window matters. And then so the problem, the solution that we can solve that problem is really to say if we can make sure the cash crop yield won't be affected. With that condition, we should stretch the cover crop window as longer as possible, such that we can gain the benefit of cover crop but also avoid the cash crop loss. Do you have a suggestion for that?
What's that?
Do you still disagree?
The reduction in corn yield appears to be not significant.
Not significant.
How many years is that? And it looks like three bushels from what I can see from back here.
Yeah, so it's like 5%.
Yeah, and how many years was that field in cover crop?
Yeah,
so to your trial?
Good question. This is the Brown Truth data is 5-year trials. 5-year trials. So yes, you're right. It's not significant. 5%. If you tolerate that, fine. So if you're tolerant that, you're lost.
But you're also talking about how much more you gain by allowing the cover crop.
That's right.
Triple in size. So.
Yeah. So I agree with you now. So I think at the end of the day, it's an economic problem, right? So you got to put everything into the economics. I'm only telling you at this moment the trade-off, and then so I fully appreciate your point because let's think about this: is if you grow cash crop and cover crop, you determine that window. And then if you compensate it by growing cover crop, that's the condition. At this moment, you are not compensated much. You have to buy seed, you have to terminate that. And the government maybe give you some subsidy if you participate in some program. You may gain some benefits by carbon credit. And I'm going to talk about that. But then this is all you can gain. And then you also need to take into account about potential yield loss if you let the cover crop grow longer. And then that's an economic problem. I fully appreciate that complexity. Yeah.
I don't know that in year 10 of your study you'd still see a reduction in corn yield or cash crop yield.
That's a good point.
I think it's part of there's got to be a systems type of conversation as well.
Yeah. Are you studying agronomy or you're a farmer?
Yeah, professor.
You're a professor. Okay. So no wonder. Okay. So. The rationale of the long-term benefit is through multiple aspects. The cover crop in the long run can help you grow, so increase soil carbon, and then potentially that feeds back into that. And then there's other aspects that also can bring benefits. So for example, you can reduce the weed, you can improve the hydrological conditions. All this is going to benefit that. All these are going to benefit. Now the question that you're asking is, when do you expect to see these benefits? When do you expect to see these benefits? The soil organic carbon, since I'm talking about that, I'm gonna address that, come back to you. So, talk briefly about soil organic carbon the soil organic carbon problem is also complicated. We did an extensive validation about our results. So it's in the ballpark of the metadata analysis. So we trust the model in the ballpark. But what we are looking at in the system, and this can be an interesting result, is in the current system, if you don't grow any cover crop, our system is depleting soil carbon, especially in our landscape. In most of Illinois land, if you only grow corn soybean rotation system, you are depleting your soil carbon. Do you worry about it? Mostly you don't need to. The reason that you don't need to is because we sit in the richest amount of soil carbon land. Our bank has give you a ballpark. Our bank has $1,000, and then every year depletion is only a few cents. So you don't need to worry too much, okay? You don't need to worry too much because we have a lot of things in the bank. Now the whole issue is if you start to grow cover crop, what's gonna happen is you're still gonna mostly decrease, but that decreasing rate is gonna slow down, and then you start to really gain that difference when you grow cover crop versus if you don't grow cover crop. And that's where the carbon credit people usually tell you, these are the carbon credits you're gonna gain, Okay, these are the carbon credits you're gonna gain. And then so associate back to my previous point, if you let cover crop grow longer time, you usually can let more carbon come to sit in this landscape because you leave the residual biomass on the ground. Some of these residual will be decomposed, get back to the atmosphere as a form of carbon, but a lot of them will stay in the soil, become the source for soil organic carbon, and they stay, and they stay. And then so this is why you start to see in almost all the cases, if you grow cover crop, you're gonna gain that benefit. And that's a relative benefit, it's not absolute benefits. That's not absolute benefits. I need to finish that. And then so I think let me just let me just finish this. So if you grow cover crop larger, you're gonna gain more soil organic carbon, and we demonstrate that. And then so we also did some work about fly airborne hyperspectrum, so we can fly over and do the sampling. We can estimate cover crop biomass from the airplane, hyperspectrum quite accurately, and then so we can actually know in this is the Champaign County southern part, we actually know every field that growing cover crop that or their biomass. I think I will end here. Enjoy that question and conversation. We should chat more, and for the sake of time, I will let the second speaker come.